Prime numbers. Prime numbers. They're amazing, right? Yes, they are. But there are a lot of questions that can be asked about them. Like, are there any specific and predictable patterns in their arrangement? Or are there efficient and deterministic tests for probable primes with non-trivial factorizations of n plus or minus 1? Or is 1 a prime number? All, or two, of these are pretty good questions. But one more question that you might have is...
How many are there?
36. Counted them myself.
Okay, so right off the bat, we have an answer. 36, and Vernon Dursley was kind enough to count them himself. Isn't that so nice of him? But was he right? Well, the 36th prime number is 151, a number with 3 digits, and according to Wikipedia, the largest known prime number as of the time of me making this video has 41,024,320 digits. So, safe to say Vernon Dursley is wrong. Sorry, Vernon. So what is the answer? Well, let me answer that question with a question. What do the prime numbers, my respect for women, and the number of tickets Morbius sold have in common? That's right. They're all infinite. Yes, I just made a Morbius joke in 2025. But that aside, the point is that there are infinitely many prime numbers. There is always one after the other. How do I know this? Well, in order for me to demonstrate it to you, I'm gonna need to break YouTube's rules for a second. Do you want to see a hairy black pussy? You do, eh? Of course you do. This'll be our little secret, okay? There you go. Sylvester. Okay, well, not that Sylvester. That one. That Sylvester. In 1880, he investigated a sequence of numbers that we can use to quite easily demonstrate that there are infinitely many primes. Its first few entries are 2, 3, 7, 43, 1,807, and 3,263,443. How it works is you take the first n terms of the sequence, then multiply them all together, and add 1 to get term n plus 1. So 2 plus 1 is 3, 2 times 3 plus 1 is 7, 2 times 3 times 7 plus 1 is 43, 2 times 3 times 7 times 43 plus 1 is 1,807, and 2 times 3 times 7 times 43 times 1,807 plus 1 is 3,263,443. So how does this demonstrate that there are infinitely many prime numbers? Well, if we assume that 2 and 3 are the only prime numbers, then the very existence of Sylvester's sequence contradicts that notion. 2 and 3 are the first 2 terms of the sequence, and the number at spot 3 in the sequence, by definition, is one more than a multiple of both of them, and thus can't be divisible by either of them. You can keep repeating this for more terms in the sequence, like if we said that 2, 3, and 7 are the only prime numbers, as if we didn't just skip over 5. Sorry, 5. Anyways, 43 is thus one more than a multiple of all of them, so we're missing at least one prime from our original list. You can keep extending that more and more, and it's a sufficient proof that there are infinitely many prime numbers. So there you go. A little bit of a short video answering the question of how many prime numbers there are. I hope you learned something from this video and enjoyed. Thank you for watching, and I'll see you later. Probably.